For our quick. All right, thank you.
All right, we're gonna begin. I'm gonna begin.
I'm excited for new math.
So there is something I need to show you.
What is it?
Which is, well, we will see.
Are we still integrating?
Oh, just think about, we have like half.
Miss Ann, what should I title the notes?
Just like, they don't need a title.
Okay.
What percent are quizzes versus tests of our?
Tests are always weighted out of 100.
I didn't get the T.
Quizzes are anywhere between like what, 18 and 22. So a quiz is usually about a fifth of a test weight. All right, let's begin, please. Okay, so we are now about to move into applications of the integral, okay? And as we go into applications of the definite integral, we're going to start with, it gets increasingly more involved. So applications of the integral, the first natural one to do is area between curves. I'm going to give you a phrase, okay? And I want to give you a phrase and I'm going to help you make sense of what this means, okay? When we're talking about the area between curves, I want to show you something.
Upper minus lower?
Yeah, just like put that down for now. That's a little key hint. And I will clarify, okay? On instead of axes with reasonable accuracy, go ahead and let's just take a look at this. Reasonable accuracy. Okay, so f of x equals 1/2 x squared plus 1. And I'm going to, let's do this one.
1/2.
Do the opposite.
That's not accurate, but whatever.
So the two rows are turning away from
Miss Ann, I just have a question. How would I move this around once I'm out of space?
Just your finger just moves it down, and
Look at that. That's so
scroll
cool.
up.
Okay, cool.
All right, I need us to begin now. Okay, so can we have our conversation and sidebar distractions kind of bring it in? Okay. Here's what I want to share with you. We're going to get to this incrementally, and one of the things, this little phrase, upper minus lower, is going to come in very handy in about a minute, in one moment. I'm going to do this here. I'm just going to shade this region that is between these two curves. And I'm actually going to do this.
At a certain point? Okay.
Yep, and I'll put that in a second. This is at x equals 0. Okay. This is going to be right here. This is the value at x equals 3/2 or 1/2. Okay. So looking at the area between two curves. I am going to ask you this question because it's so important that you actually understand why these things work. This is the picture you have. I'm going to put up several integral expressions, and you are going to tell me what that represents in the context of this picture. Okay? First one is this one. I just realized something for clarity, so we're being succinct. See how I called this y equals 2/3 x minus 1? Let's just call this g of x, so we are able to distinguish the two.
Oh.
Okay. All right. So that's the picture. That's going to be the picture from which we do much of our work today. What I'm asking you to do right now, you can talk to someone next to you. This integral expression, first of all, is a positive or negative number. That's the first thing. And then what does that number relate to in terms of this graphic? Okay, you can have a convo with someone next to you. And did you put that picture on there, Shreya?
Yeah, it's on the side.
Very good. Yeah, you can use like highlighters or whatever over here.
Oh, cool. Okay.
Fairly certain it's positive.
Okay. What is that? Is that number positive or negative?
It's the area between, I don't know, what would that be?
The x-axis.
Y equals 0, yeah, x-axis and the curve, and f of x. Sorry, what you had?
Oh, okay.
No.
So.
It's really hard.
Oh, right.
Yeah. It's really hard. If you're like, okay.
That's what I thought.
Oh, wait, from x equals
Okay, well, hold on 1 second.
From...
Mateo, qu'est-ce que c'est? What is this? Positive or negative number?
Positive.
This is a positive number, and what does that number represent in the context of this picture?
The area underneath the curve to the x-axis from 0 to
Okay, it's right here. Agreed, everyone?
Yeah.
All right, next one is this one. What does this represent in the context of the picture? Is it a negative number? Is it a positive number? And what does it represent in the context of the picture? And Kate just made a point. This is actually, that's the point I want to make to you seniors moving on. When you take your next level of math class, in college in particular, when you are told just kind of what something is without really understanding it, you have to recognize that if you learn that way, you are very limited in terms of the kinds of problems you can answer, right? So if you don't know why something works, you have to know why something works for you to be able to work with it. You're a little bit limited in what you can answer if you're just told the answer is because. Okay. Gary or Cameron, positive or negative number, first of all?
Negative.
It's a negative number, and what does that number represent?
The net side area.
Okay, so this is going to be, that number is negative. It's a negative of a number. It's a negative of this number right down here, okay? I'm just trying to distinguish the two. All right, now I'm going to show you this. So this is some positive number. This is some negative number. It's a negative of the number that is the area below. So then what is this one? The definite integral from 0 to 3/2 of f of x minus g of x dx. What you just told me to forget was the definite integral of f of x. This part here was a positive number. The definite integral of g of x, this part here was a negative number. So if you have positive number minus a negative number, tell me at the end of the day, will this number be positive or negative?
Positive.
It's a positive, and what does that number represent?
Area. In
The area.
Total area?
It's the total area, the actual area between the two curves. We don't need a word net. It's just the actual area between the curves. Bounded, okay, now look, bounded over, I'm going to add more here, over the interval, and they are bounded over the interval of x from 0 to 3/2. All I'm doing is kind of formally giving you some language here to put some mathematical meat behind our intuition. So it's the area between those curves bounded over the interval from x equals 0 to x equals 3/2. No coincidence that this interval are the limits of integration, okay? I'm actually going to add some more here for a second because we're going to talk about functions of x today. We will swing to things that are called functions of y the next time I see you. But now do you see why? Look at this phrase, upper minus lower. So if you're looking at the area between two curves bounded over some interval of x, you're looking at the top function minus the bottom function, okay? Upper function minus the lower. Okay, yes, Oliver.
Is it possible to do if they're both below the x-axis?
You read my mind. Okay, read my mind. Ready? Here we go. Let's see. So, and again, this is a case where I could just answer Oliver's question yes, but that would be very, very limiting. So look at the situation here, okay? Here is a function. You ready? Let's take a look at this one. Okay, I think I'll go with, I know. Here we go. Okay. This function here is, let's call it f of x. F of x equals -1 over x. And I'm going to do this function here. I will do, I have a really good one. What this one? Okay.
Oh, what's going on?
Oh, this looks
Negative 1 over.
Whoops. Pardon me. Nope, we're good. What? No, we're good. Never mind. Never mind.
What is that? Is that tangent?
I'm sorry, no. This is g of x, pardon me. G of x equals -x cubed. So sorry. And here is the area that I'm going to find, okay? little bit interesting. The area
Which
here.
area you
Why haven't you yet? We could just wait. Hold the phone, all right? Let's say it's gonna be from here to here. You ready?
From there. Oh.
Oh no.
I didn't draw it like that. Damn it. Yeah, my drawing is wrong. I can't. Wait.
Aren't you showing up this?
Yeah. This is kind of unfortunate. You're right. Oh my god. Okay.
What?
Miss Ann, what are you doing?
Well, how can this suck?
I'm just gonna redo it. I'm so sorry. Whoever's like using this for notes.
I actually hate that word. I don't like it at all. Can you not say it again?
I will not.
Say I'm very sorry, Miss Ann.
I'm very sorry.
Where's that?
I think it's just.
What's
I
the
think it's just
function?
a C sounding word. I don't like super consonant and words.
Oh yeah.
What about, like-
Big. It's a CK.
So then what do you call like a aquatic bird that wades in water?
What?
A duck.
What?
Yeah, the penguin.
A penguin.
Back it up.
What's the
Okay,
lower?
that's
Miss
seven.
Ann,
Back it up.
what's the lower?
Seven.
bound?
Seven.
What's the lower bound?
What's that intersection? Oh.
The lower bound. It is the point of intersection, which is at what?
Some point that actually happened.
Miss Sam, I just want to let you know that I'm really bad at this.
Right, cool. Wait, that's
Yeah, of course, Miss Ann.
Now.
How could anyone ever?
Again, I'm sorry.
Is that 1?
one.
Is it 7?
Okay,
Okay.
now hold on a minute,
Okay,
please.
6, jinx it.
Same exercise now.
Actually,
all right? But over here,
I'm gonna
put several integral expressions up. Are you ready? What is this going to be? The definite integral from 1 to 7 of f of x dx. What will that be? Negative or
makes it
positive?
better.
And what is it in the context of the picture? The next thing I'm gonna ask you is the definite integral from 1 to 7 of g of x dx. Again, it's what's really important. This is what, and I think in some ways I kind of
Miss Sam.
not really giving you an option about really understanding why the math works. Because here's the thing. This could have been a 30-second telling you what the rule always is. Upper minus lower. It's always upper minus lower.
Stop changing.
Then all those like juicy, twisted questions, you're stuck. You don't know how to do it. Kate, positive or negative number?
Negative.
This is a negative number. Okay, now, what does that number represent in the context of this picture?
From the area from the x-axis to f(x).
From the x, yes. So Kate's saying that's a negative number, and it's a negative of this number here. Okay? And I'll make it negative here, so it's green. That's a negative number, and it's a negative of this number, so to speak.
Wait. That integral is the green
This
stuff.
integral
Oh,
is a
whoa,
negative
that's-
number,
And it's the green stuff on that.
and it's green.
Because I just got it.
Is
It's
it
like
okay?
upper
Now.
minus lower because it's like that, but you minus that part.
Okay, let's see. Ready?
Wow. Maybe next time I'll understand limits.
Positive or negative number here?
Negative.
Negative number, okay. Give me a description of it. It's a negative number
Oh, I get it.
where? It's what graphically? What is it? Can you
It's
tell me?
both of those. Wouldn't it?
Okay, yes, it's a negative number and it's all of this.
Yeah.
You
The
understand?
total
Wait.
area.
The total net
Under-
sign here.
Wait.
Okay.
So is it?
It's all of that.
Okay, I need you to rate, I can't hear a question. It's important. Okay, Walter, thank you. Yes, Oliver?
So is g of x the area from the curve, but then it's bounded by f of x, or does g of x go all the way to the x-axis?
No, so you're asking about this integral here?
Yeah.
This integral, you basically erase f of x entirely.
So it goes
It's
from.
all this right here.
Okay, yeah. I
But the
thought.
negative number of that,
Oh, I thought we did the next one.
okay? Now, here is where we're going. So this is going to answer Oliver's question. These are both negative numbers, but you see graphically that one is more negative. So what would this be? The definite integral from 1 to 7 of f of x minus g of x. Again, it's the upper minus lower. You just said f of x minus g of x. These are two negative numbers, a negative number here minus a negative number here. What is the answer going to be here at the end of the day? A positive number, and it represents the what?
It's the area from G of X to
Let's write it down.
Upper or low? Upper minus
One second, okay, let's do it. Ready? Area between f of x and g of x, let's write the whole thing out. Over, let's see, over an interval of x, correct? And the interval of x happens to be from 1 to 7. Upper versus lower, Arjun, is you're scanning your coordinate axes vertically. You scan it vertically. This is above this curve from 1 to 7. So like over this interval of 1 to 7, this term, this function is literally above that one.
Okay, so then we can just
Upper
subtract.
minus lower, correct. That's why the little key phrase is up there. Upper
So it
minus
doesn't really
lower.
matter if f of x or
I'm really
g
bad
of
at
x
taking
is-
notes on the computer.
Upper minus lower.
I'm so bad at it.
Okay? Now, here is what I want. I would like you to cobble together. Let's go over here and sketch this now.
Again, okay.
Okay? Let's sketch this. May I erase this?
Yeah.
I'll go over here. Okay?
There was a math 2 class before this.
Okay. Here we go.
Oh. Here's this do.
Yeah, right.
Okay. Missy Ann, what does clicking the pen do?
I actually don't know.
Because I just clicked it and nothing happened.
Yeah.
It does nothing.
I don't know, doesn't it? fx equals sine x. Here is
Cosex? Yo,
all for
that's so dope, Miss Ann.
Right, like
So-
this.
Wow, look at that. Okay, I should draw it, actually.
Oh.
I don't understand.
Jason, do you know what dope means?
Do you know what
I
dope
do.
is?
But
No, you don't, Jason. It's ridiculous.
Jeez.
Jason knows all the slang.
Do not get into.
Jason knows all the slang.
Jason is old. He invented the new English.
Oh, I have to draw it in a different color.
Jason knows.
I'm very bad at
What is a mem?
What is it, man?
Jason, you don't know what a mem is, right? A mem is when someone says this is
mem?
a
Oh.
a mem.
Thanks, Kiri. Thanks for that.
Oh,
Wait a minute. Wait a minute.
I mean, you threatened to beat me this year as retaliation.
It's retaliation.
Whoa, wait.
Bruh.
I haven't changed an area yet. I would like an
That's supposed to be
integral.
cosine?
Listen, an expression involving one or, if necessary, two or more integral expressions that describe this area here. Oh, excuse me. This is g of x equals cos x. Okay? I need, and again, all I will give you is this picture. I want one or, if necessary, two integral expressions to describe the area shaded here. Here's what I'm gonna do. Ready?
Oh, wow. That's
About
very
that, yeah.
Now, I have something else to tell you. I want you to generate two different sets of integral expressions that could describe this area. One of them may just involve a single integral expression if you recognize the symmetry here. The other one has to be two. Okay, so I want you to describe this area.
That's symmetrical?
Yes. this
Okay,
one.
I'm gonna write that because mine does not look symmetrical.
God.
How are we supposed to know?
Arjun. Arjun. All year last year.
Missy Ann, just for the
All year.
All
future,
year.
I'm not very good at
What's
taking
the lower
notes.
bound?
Values.
I will not tell you.
Look at the graph.
Megan says, what are the values?
Okay.
I tell you nothing.
Pi over 2.
Is it? Yeah.
No, it intersects at pi.
Pi is a big
It's pi. Yeah, it's
I
pi.
was not talking about the intersection.
Yeah, I'm pi.
One
Yeah.
is pi and one is.
I thought it was
So
pi and
for
3 pi.
sine, it's 0 pi, 2 pi, right?
What am I talking
No.
What?
No.
Yeah.
It's pi over
The-
4, pi over 2.
Man, we need to
3
go
pi
back
over
to
2,
trigonometry.
I'm saying for sine, where it intersects the x-axis is 0, pi, and 2 pi. Thank you.
Technically.
So
when
it's-
it's,
yes,
when it's
so-
at pi, it's a negative.
So the beginning is pi over 2. What I said at the beginning.
Beginning is still pi. What do you mean? Your sign is 0.
It's so funny, you want, never mind. You will not get me on. I thoroughly enjoy.
And then, oh, hey, this is.
Okay, what is it?
Yeah, I don't know what the value is.
Oh my
wait,
god, what is that point? What is that
I'm
point?
about to eat all of this.
I'm telling you.
This is so off.
Oh, I got it.
I'm so sorry.
He didn't say anything.
Second time today. I don't like the. It's really boys.
Hashtag not all men.
Not all men.
Not all men.
Oh my god.
But you didn't answer me, so.
Yo, what's in between pie and pie?
What point are you talking about?
Oh wait, pie and pie. What's that one in between?
3 pi over 2 is.
Why?
What's the one in between?
Do you all remember last year?
4.
Were you there? The day when Daniel.
Look at this. Look how off this is, Meg. 3 pi over 2 is here, but the 3 pi over 2 is over there.
You know she hear everything you're saying.
Yeah, I know. I'm so sorry, by the way.
Why did you
She destroyed his life.
My BC1 class was the worst experience.
Yeah, mine was terrible.
Yeah, my BC1 class was so bad.
First, let me just say, I was the dumbest kid in the class, like, by a mile.
Yeah, oh my god.
Everyone in my class.
I don't think they.
Out of the zone.
Out of the zone?
No, I'm like sitting next to like Adam the Zone. He's like, yeah, I get the
These people like they were like,
did not let me know. Like she told me how to find the derivatives, but didn't tell me what it was. I'm like 2.5 weeks into that, and we had like 5 assessments in that time. Rest in peace to my grade, and that's AB.
Okay, no, she taught us like the definition of the derivative, which is like the limit of like h goes to 0 or whatever.
Did you notice
and we didn't learn.
Singer? No, right?
Oh,
I had it. Oh,
Shana?
Just to be clear.
Chana.
Shauna?
Shana.
Chana.
Okay, will you all please?
Well, I'm thinking of the name correctly.
Geary,
Wait, I think about.
if I ask you a question, what comes out of your mouth should be
Is it
wrong.
out?
I'm going to beat you.
Yes, I did it.
No, it was not.
Well, I did it in my
Oh,
head.
okay, so
Okay, ready? Listen.
it's the integral from pi to 5 pi over 4.
The definite
The
integral
definite integral
from
from pi to
pi.
5 pi over 4.
Yes,
Of
Geary.
sine of x minus cosine of x.
Oh my goodness.
I know.
Ugh, I'm not writing this right.
Yes. Plus,
Look at that, that's so
the
bad.
definite integral from 5 pi over 4 to 3 pi over 2 of cosine of x minus sine of x.
Why?
Oh, that's what I got. Nice.
Wait.
Biggie, Geary.
That's correct.
Oh, okay.
The reason why we can't combine these two, there are 2 reasons. Number 1, the integrand is different, and number 2, the integral difference requires 2. Can someone think of a way to express this with using only 1 integral if you had your grill?
Like a 2,
Yes.
and then
2 times
just do either one of them.
either one of those. I'll go this way. Pi. Good job.
I'm
Pi.
such a bad student.
Yo, that's pretty sick.
Did you say you're such a bad
I'm
student?
such a bad student.
So innovative.
Okay.
You know, putting the 2 in front of the integral.
All right.
Wow. They should just send me to Silicon Valley. I know.
Ready?
Wait, no,
Just give me my degree in math.
What, Harvey? Is this last period?
Yes.
Believe me, can you not tell?
No, I feel like I like it. It's like a more relaxed atmosphere. I feel more ready to
Pi
learn.
to 5 pi.
Every day is a Friday feeling. Like, why is the
It's because it's a post-test math, so I feel relaxed.
What does
there's
that
no
mean?
stress.
That you're so ready to get out.
Every day is a Friday.
What does that feel?
homework? But if you pay attention in school, you can't do homework by the end.
Yeah, it's true.
Yeah, that's true.
So you either
You're, like,
go
so
pay
exhausted
attention
by
in
the
class
end.
and learn home, or you
Wait, Miss Ham, I can't see like the. Thank you.
Honestly,
Sign
that's
of
such a
it.
mood.
Next one.
Yeah.
Screen recording?
Yeah.
Next one.
Oh wait, who's this for? Hello. I hope you're feeling better, Paige. Oh
It's
wait.
the most like.
I think they have 10.
Yeah, they have tennis.
Oh, good luck at tennis.
Good luck in advance, or if you're already doing it, I don't know. And I apologize in advance, or already for my crappy notes.
That's time.
Ready?
Wait, again? Oh my god.
Okay, I need,
I'm so ready.
well,
You're making me draw too much.
She used to draw pigs all the time.
She did, I remember that.
okay, you know what?
Eggs?
Yeah, she speaks like
Wait, is there a way that you can make a smiley face with the area underneath a curve?
Ask
Yes, make
Jason.
2 points at.
Wait, hold on.
Jason, you wanna know what Jason
Oh, yeah.
did?
Jason drew a smiley.
Can you
Sure.
find the interval?
What is that?
Yeah.
Okay.
Did you say that you find the interval?
Yeah, the area underneath the smiley face.
Okay, here we go.
Is this-
And now, as you can imagine, these get,
Very-
whoops,
This one is
This.
here's a shaded area.
Flex
Shaded
out.
area is right here.
Where is it?
Arjun,
I feel like you do it on purpose.
I know, and you wanna know what's so funny? I
No.
can't tell you actually.
No, tell us.
Well, now you have to tell
Now
us.
you have to tell us.
You have to tell us.
RJ.
Sam, expose
Miss Yam,
it.
don't worry. Teacher student
Don't find it.
confidentiality. We won't snitch.
Okay, let's chop. Next one.
My 7-year-old neighbor says chop chop.
Timelessly wise.
Sure.
That to me is a
Go on, Peyton, go on.
Dragon that we draw.
Square root of 8.
Oh wow, that's kind of sick. That's really cool.
Yeah, we draw this dragon.
7-year-old neighbor. 7-year-old
That's
neighbor
awesome.
saying chop.
17.
17. Oh.
I heard 7. I heard 7-year-old neighbor too.
What was 4 is 8? Square root of 8.
Arjun, let's go.
Square root of 8 is what?
I mean,
Same
thing over.
Square root of 8 is not 2.
2 root 2.
Oh.
Listen, if you substitute equations here into each other, if you use 4 is equal to x squared minus 4 plus 4. Yeah, okay, thanks.
You're welcome. Okay, wait. This is. I have to say that this that
He hushed the crowd.
corresponds with that. Okay, I'm good.
No.
Aha, all right, you know what, and then after we do that, this was next, okay? And this is kind of what will lead us, moving forward here.
I feel like I've been doing a whole ton of math.
I'm just gonna draw this now.
I'm learning to color well though.
Very
Color, yeah, I can't color inside the lines, but that's okay.
Wait, are you supposed to find the answer or you just want us to set it up?
Yeah, I just want set up, just set up.
Oh, we're doing this crazy.
All right, this is kind of the next place we're heading, okay?
Oh, is this right one?
Yeah.
Nope, The area here is this one, okay?
Y equals square
Now,
root.
this is gonna require some thought. Okay, that's the last one. I mean, sorry, that's the next, that's kind of where we're heading to next. Be careful.
Here.
Okay?
Which one's Y and which one's?
Oh, you know what, you wanna call it f of x, I just gave them names here. All right? And yeah, Megan asked a question, do I want you to actually evaluate them? No. I want you to set up the correct integral expression. Okay?
Wait, I don't know why this one's different from the others.
Ooh, Jabril's saying, I don't know why this one's different from the others. I'll let you sit with that for a second.
Wait, can you tell me?
Don't give it away, don't give it away.
I wasn't, I want them to, struggle a little bit.
Did you just subtract the thing?
Oh,
I know.
Wait,
I
no,
know.
wait, just tell me.
No, Jabril, why would you insult yourself that way? You don't want to just know.
But I don't know how I'm gonna learn like organically.
Yes, you do,
Just from
Walter.
staring.
You're not learning about yourself, but like, just think about it,
Listen, it's
okay?
this.
Yeah, you do.
What is that?
Now,
Do you have to do 2 angles for y equals x squared minus
2.
No, you do not.
Yeah, because it's x squared back.
You could, but you don't have to.
But how do you?
There's more.
according
Oh
to
my
the
lord.
area under y squared minus 4
Or I should leave more room to write.
Should we
it intersects with the x.
Huh? What?
That's a really good question.
So do you have to use 2?
You don't. So you're saying, I know exactly what you're saying. That's a really good question. You're saying that when you, if I were to break it up, kind of like how I did it before, this value here, what is this value by the way?
2 root 2.
2 root 2, okay.
Every day.
Is it root 2? Is that what it is?
It's 2 root 2.
Okay, so if you did, so Oliver, you're saying if I did this to root 8 x squared minus 4 dx, right? You are right in saying this is gonna be a positive number, and it includes this actual little segment here.
Oh,
Correct.
that's why.
No, it's this is the answer here, no. The answer here is still 0 to root 8, 4 minus the quantity,
Oh.
x squared minus 4 dx. Okay, that is the correct answer. That's the correct answer. But Oliver's point is, if you kind of break this up, like this alone is, yes, it's this right here. Look. It's all that, it's a positive number with this like extra little piece here, right? All right, but then look at this one. The definite integral from 0 to root 8 of 4 is going to be what?
Four times root 8. 4, 8, 4 root 8, yeah.
4.
Dx equals. So this is going to, do you see what I'm looking at here? This is the entire rectangle.
Yeah.
You understand? Oh wait, I'm
You-
sorry.
yeah,
I just
you-
thought it was, I just made a
So
mistake.
it would be
I'm sorry.
the curved bit.
This is the red, yeah.
Wait, yeah,
So
that
it
would
would be
be
the
the
curved
rectangle.
bit and then the bit outside of the curve.
Yeah. I just put it backwards. This is this bit and
Plus
this bit,
that bit.
Yes.
Yeah.
right? But it's still gonna be a negative number. Agreed?
That's
It's like
bigger.
negative here than positive here.
So it doesn't matter.
No, hold on. So this is a negative number,
Yeah.
right? This is some positive number, and this is the red.
Yes.
Okay? Now, if I do this, the definite integral from 0 to root 8 of 4 minus the lower, look what happens. So it's the red positive number minus this negative number here, right? Because this negative number, so this would be the red minus the negative number. It's the red minus the negative. And when I take, and this piece of it, like this overlaps, it cancels to the out.
Could I do it in 2 separate
You
intervals?
certainly could. You wouldn't need
Would
to.
that be, what would that look like?
I'm not sure.
Would that be,
No.
you would have to do from 0 to 2, and
Yep,
then 2 to 2 root 2.
Yeah, this is actually, what we're having is a really good conversation, everyone. If you're not listening, you're kind of missing out.
He's gonna call you back. Like,
So here's what you could do. This is what Oliver's saying. He is saying, couldn't I just do this? You'd want to say, do what? Tell me your 2. Go ahead.
From the interval from 0 to 2
To 2.
is where the,
Ah,
is
I
where it
see, yep,
intersects
to
with the
2
x of y squared, or x squared minus 4, I'm sorry,
dx.
dx.
Okay, now that is going to be a negative number.
Yeah.
Okay.
And then the positive number would be the interval from 2 to 2 root 2 of x squared minus 4 dx.
I'm confused. I have no idea what's going on with this one.
I'm just, okay, so this is going to be a positive number.
Yes, it is
I
positive.
don't know.
Okay,
I don't know
keep
what's
going.
going on.
Basically, whenever you don't do 2 separate integrals, then you're just doing it all in your head. Like you're doing it in one step.
Correct, but listen, this one
The one in
though,
the
you
red?
haven't got, I don't look at the area in green.
In red.
No, the area in green was the original question.
No, I'm talking about
Yeah,
but
yeah.
yeah.
So
So,
you're not done, are you?
no,
Okay, how would you keep going?
but then you would have to. Okay.
This is actually a very, you're gonna see something in a minute here. So
Sure,
Oliver's
okay.
trying to, go ahead, keep going.
I don't, you do, the first integral plus the second.
This plus
That-
this one?
Yeah.
Well, but wait, you just told me this here is just this here, it's a negative number.
Yeah, and then you add,
This-
and then you.
No, but look, Oliver, honey, this here is just this.
Yeah, no, I understand, but my point is, that whenever you do the integral from just here to here,
Right,
you're canceling out this one because it's a larger negative value than this is a positive value.
right,
So I could do it with 3 integrals. I could do it
right.
the integral from here to here, the integral from here to here, and both of those are of this function, and then I could do this the integral of this function
Right,
from here to here,
right,
and then I would put them all together.
okay, so then, let's see, so you're saying 0 to 2 root 2 of 4 dx,
Yes.
correct? So you're saying this plus what?
What is this?
This plus the opposite of this,
Yeah.
and then subtract out this one?
Yes. Does that work?
That is fair, but wait a minute.
But it's
Look,
just more complicated.
no, but look, if you go this, so you're saying this
Yes.
plus this minus this.
Yes.
Okay,
Plus
so watch, that's the same thing as this, watch. Integral from
that
0
minus this plus
to
this.
root 2 to, yeah, hold on. 4 minus x squared minus 4 dx. That's this. that's here, right?
But the,
Oh, yeah, sorry, you're right, sorry about that. Okay, so integral 0 to root 2 4 dx minus 2 to root 2 x squared
Watching
minus
this,
4.
I feel like I'm getting worse.
dx.
Oh my
And then what's the rest of it?
Like, what is happening?
You wanna add that?
yeah, because you're adding negative. Yeah, because this is a negative, this is now a negative number, a larger negative.
No, you.
We're no.
Try.
Yeah, same.
Trey, how you feeling?
Huh?
You're making this little, small negative.
Right, so you wanna.
Yeah, for German club. For German club, they're making gummy bears.
So actually, wait.
Yeah.
No, that's
Would be
fine.
negative.
This is a positive number minus this positive number. Yeah, no, that's
Finish.
plus that, which is a
Can you
negative.
send me a picture of your
Right.
So this is. But that in long, this is the long end of this.
Correct.
Yeah, so I can do it this way.
You can.
It's just a long.
You can.
It hurts my head more.
Wait, Miss Yan.
Yeah.
It would be a negative there, though.
Here.
Yes.
Well, it's a negative number though.
So that would make it a
0 to
positive,
2.
so that wouldn't give it the wrong.
It's a negative number, so if you subtract it from the value, it makes it positive. Like.
Oh, this
every-
was right. This should actually be minus Oliver, and this should be plus. You're backwards.
Yes,
It's minus and plus. Yeah.
Wait.
You're
Can we go back to?
Wait.
Wait, it should.
No, why, no, just please, I'm begging. I am so lost. It's like you guys dropped me in like the middle of like the sub-Saharan. I have no idea what's happening. So, can we please follow just the areas of like just 0 to root 8, 4 minus, because I'm not,
This?
yeah.
Okay. So all I'm saying is that the green area, that was the original question, the area question.
Yeah.
And all I'm saying is you notice that area in green is bounded above by 1, like this is the above function.
Yeah.
And here's the below function.
Yeah.
That's all. And so when you take the integral from 0 to 2 root 2, it's just the upper function, which is y equals 4, minus the lower function, x squared minus 4. That's all. And Oliver's saying he just did it in pieces.
I did it.
But but wouldn't that also include that little like sliver like after like that where you
That's what I thought.
That's what he was saying. Okay. Yes, it does, but here's the
It
thing.
cancels out because the negative is something.
Right. So so that you are asking a very, very good question. So when you do this, let's take a look. 0 to 2 root 2 of x squared minus 4 dx.
Oh wait, they cancel out. I just saw it because of
Do
the.
you see what
Yeah,
I'm
I just
saying?
saw it. Yeah.
Okay.
Yeah.
See, I thought the same thing, that's why I thought you had to separate.
You
All
don't
right.
have to separate. Okay, this one is not the same. How do you do this? What do you do? What do you do, Jason?
You do 2 parts.
You absolutely need 2. So this is one where this region right here,
It's just a net sign area under the curve.
it's the definite integral from 0 to what?
Two.
To 2 of which curve?
2 to that.
2 to the x dx.
2 of x.
And then
Definite integral
from
2 to 4
of
upper minus lower.
2 to the x minus root of x minus 2. And do not forget your dx's. Okay? All right. So do you see how that cancels out?
Yeah, I just saw it.
Yeah, I think I made like a leap that was a little bit too far. Okay, tonight's homework is on area between curves. You can go ahead and pause. There's another part of your